video, we talked about all the filters and including looking at the reference and representative genomes, which is the default, and then all the public genomes and how it does blast against those genomes to find the gene of reference. And then it brings in the upstream and downstream genes, and you look at those. Recently, we updated the viewer so you could view your genomes, your data of interest in this viewer. So in this video, I'm going to show you how to do that. And so the first thing, let's look at the genome groups. So first you have to click on the down arrow here and then click on selected genome group. And then you say, well, now what do I do? Because it looks like there's a dead end here. This wraps, you have to go over here. And I guess it helps that it's got this folder icon shaded. And that is to take you to your workspace. If I clicked on this, it would open up a dialog box with my workspace, but I don't want to do that because I can click on this down arrow here and it's going to show me what groups I created from the most recently created on down through time. So let's look at the ampicillin resistant genomes. Those were the genomes that we have in the BV-BRC resource that were from isolates that were shown to be resistant to the antibiotic ampicillin, and we have their DNA here. So I've included that, and now I have to click on the update. And then we wait. Okay. And the image finally loads. And so these were from, like we said, the ones that were resistant. And if you mouse over some of these genes, you see mobile element protein. Mobile element protein, here's a red one, a mobile element protein that seems to be in a different family. You notice that this one has numbers, this one doesn't, indicating that these belong to a protein family, but there aren't enough of these guys to be united into a protein family. Now, what does it mean when you see mobile element protein? To me, it screams horizontal or lateral transfer. We all know that antibiotic resistant genes often come into a bacterial organism by horizontal transfer with like plasmids or phages, things like that, or insertion sequences that they're jumping around inside the genome. So when I see that, I'm immediately thinking, oh, this is something that's being passed around. Now, let's look at the upstream and downstream regions. And in this genome, and in these genomes, and in these genomes, you can see that they're very similar in the upstream and downstream regions. So at least among these resistant genes in Haemophilus influenzae, these are in a similar context, a similar genomic context. And then you have this guy who ends right here and has a small blast hit. That's in a very different context. And that one has a mobile element protein as well. One thing you might be confused about is they're arranged by blast hit type, but not when you're looking at your own data and you've created this group. In this group, it's not saying that this had the strongest hit. That's not true at all. This is just the order that they occurred in the group, and the viewer resolves it that way. So you've got this context of it, this context, and look, it's also got some mobile element proteins. And then we have this context, which also has mobile element proteins. So I think this gene moves around a lot. So this is in the resistant ones. Let's look at the susceptible ones. And there's another way you can do that too. I could start typing it and it would narrow down my search there. So I click on this and I click on update, and then we wait. Now there were more genomes that were susceptible and more genomes that were resistant than we saw in all of these. Even though it says there are 10, I'm not seeing 10 genomes here. So this gene didn't exist in the other ones. and it exists here. And remember, with the resistant, there were 72, and we didn't see that many genomes. So it's an indication that some of these genomes have it and some of them don't. Some of the isolates had it and some of them don't. Now it looks like here you can see that we have the same kind of situation of the upstream and downstream region being tightly conserved, but I want you to pay attention to this. These are all in the same genome. And here is where that blast hit comes in handy, because you can see that there is one copy and there are likely two copies in this gene, and that this one is probably broken, and this is at the end of a contig, and this is at the end of a contig, and maybe they belong together. And so it can give you some indication of correcting an assembly or for your assembly errors. Okay, now let's look at the feature groups. So I'm going to click on the down arrow here, and then I click on a selected feature group, and I'm going to click on the down arrow here. And let's look at the genus-specific feature genes from the complete genomes. And I'm going to update that, and they should all be within the genus Haemophilus. And now we wait. And so how many do we have here? Oh, it's showing everybody in the group that had this gene. So here they all are, and you can see that they're different flavors. They're these guys, these three that have both similar upstream and downstream regions. And notice that they're from two different species, okay? Parainfluenzae and influenzae. And then you have like this one, which is an influenza genome, and that one is similar to this one, which is parainfluenzae. So you are seeing two different types, two different fields for these things. And then you see the Ducreyi genomes here that are similar in the forward strand, and things start falling apart in the reverse strand, although this guy is close to this guy. So it's an interesting way you can sort of start seeing the power of this and how you can see where this gene is, how it's entering the genome. If I mouse over these, the mobile element proteins, it's an indication to me that the gene is jumping around and moving around. And if I wanted to look a little bit broader, I could look at the global family, which is cross genus. So let's update the view and see that. Okay. One thing I want to point out is here it says 10 genomes. It is a lot more than 10 genomes. So what's going on here when you're deploying the feature or genome group, all of that goes out of the window in terms of genome number. It's going to show you exactly what you've got. And so in the cross genus family, oh, look, here we have the Pastorella right here. Remember when we created those groups, we saw that there were two that were outside when we looked at the cross genus protein families, and we looked at the taxonomic family Pasteurellacea. Within that, we had Haemophilus and Pasteurella, and here are those two Pasteurella genomes here and here. And it would be nice if they were right next to each other. They aren't. You could game it by forcing the issue by creating separate genome groups and loading those. But the rest are all within Haemophilus. Now, in the next video, we're going to talk about exporting this data. So stay tuned. I'll see you there. Bye.